Hello, Dr. Thorman. I did the tracking system for Fido, and what I originally set out to do was to follow the curve of a function. I decided on the square root function because it seemed the most appropriate, and it could, depending on the coordinates, I could fit the line to go through the coordinate given to me by the code that receives the JPEG image that the robot takes, and that turned out to be really good on paper, but in actuality, to implement it became really complicated and difficult because I didn't have enough information on the specs of the motors, and basically just the robot entirely was inconsistent with measurements. So trying to manipulate the robot's motors to follow a curve like this would have been really difficult. So instead, what I ended up doing, without even noticing, was causing the robot to just kind of sit here in this spot, or basically right here, at the origin of the fake overlaid coordinate plane that we can imagine would be in the image that it sees. He would see a dot in a certain range here, and when he sees it, he'll turn to it and then go for it. So it's kind of like if a dot was here, it would make a turn of a certain degree and then aim for it right there, bam. That turned out to be the best solution. Kendall also came up with a similar solution, and his was a little bit more refined, so I took parts of it and included it into mine. I also came up with a function to kind of slow down the robot depending on the distance that it was from the dot to reduce motor speed. I'm not sure how effective that is because the robot kind of attacks the dot in 10 millisecond increments, 10 millisecond bursts of 100% motor power, and so I'm not sure if that's even enough to really make a difference in the speed, because it's eventually going to slow down anyway, because it only goes 10, it only takes a jump of 10 milliseconds in running speed. So yeah, basically the robot goes for the dot at a line. It'll try to follow the dot by spinning in small increments, and it keeps a certain distance from the dot, which we set it to be 30. And so that's how it works. That's what I did. It would have been nice to do it the cool way, like a missile, tracking a target. But yeah, I'm not a rocket scientist, and I didn't have enough information either. So this was our solution.